Hi, so I'm going to go over this proof for you, and it's a big jump from what you learned yesterday to this. So let's talk about what you're trying to prove. You're trying to prove that SA bisects angle BSR. So SA is this, and the angle that you're trying to bisect is this. In order for you to say that that is true, you have to somehow prove that angle 1 equals angle 2. That should be your goal. So my goal is that I want to get angle 1 congruent to angle 2 because they're not right now. All right, so let's see how we can do that based on what we were given. So we were told that AS is parallel to BT. I can see those parallel lines, so it means I'm going to be using some of those parallel line equations. And I also see that they tell me 4 equals 5. So these are equal. Okay, so based on the parallel lines, I can see that 4 equals 1 because they're corresponding. And I can see that 2 equals 5 because they are alternate interior. So therefore, I can use the transitive property to connect 1 and 2. All right, so how am I going to do that? Well, I'm going to get started with my given. And I'm going to do AS is parallel to BT. And the measure of angle 4. Now, you could separate the givens here, but I'm not going to do that. Okay? All right, so that's given to me. So based on the parallel lines, I'm going to work with the parallel lines first. Then I could say that the measure of angle 1 equals the measure of angle 4, and that would be because of the corresponding angle postulate. The corresponding angle postulate says if 2 parallel lines are cut by a transversal, then corresponding angles are congruent. All right, so I've got 1 equals 4. That came from the parallel lines. I have another thing I can get from those parallel lines, and that is that the measure of angle 2 equals the measure of angle 5. Okay, now that's a different postulate or theorem, right? Those are alternate interior angles, and yesterday I proved that to you that they would be equal because of the alternate interior angle theorem. The alternate interior angle theorem, which says that if 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. So now I can see that 1 equals 4 and 2 equals 5. So therefore 1 equals 2, okay? Because 4 equals 5. Okay, we said 4 equaled 5. So depending on how your teacher might want you to do it, I would let my students go directly to the measure of angle 1 equals the measure of angle 2 by the transitive property. But your teacher may want you to substitute 2 in for 5. So they may want you to do the measure of angle 2 equals the measure of angle 4 by substitution, and then the measure of angle 2 equals the measure of angle 1 by substitution. I'm not really sure how he's going to want you to do that. Every teacher's kind of going to do that slightly different. But now that I know that angle 1 equals angle 2, I can say that SA bisects angle BSR. And that would be because of the definition of an angle bisector. The definition of an angle bisector says that if a segment array bisects an angle and breaks the angles into 2 congruent parts, then it is an angle bisector. All right, now this is how I would do it. And I used measure of angle in this case because they started off with measure of angle. You know, some teachers might have you go with the congruence and then turn it into the measure of the angle using the definition of congruence. It's just not something I do. So you're going to have to be really cognizant of what he expects of you in that regard. But this is the process that I would be following to get to SA bisecting BSR. All right, hopefully that helped. Have a great day.